So hello everyone, in this video we'll be solving another LeetCode problem, and the problem name is count unguarded cells in the grid. So let us read the problem statement first. So you are given two integers m and n representing a zero indexed m cross n grid. You are also given two 2D integer arrays, guards and walls, where guards of I equals to row of I comma call of I, and walls of j equal to row of j comma call of j, which represents the position of the ith guard and jth wall respectively. Now they have said that a guard can see every cell in all four directions, that is north, east, south or west, starting from their position unless obstructed by a wall or another guard. A cell is guarded if there is at least one guard that can see it. Then the question says that we need to return the number of unoccupied cells that are not guarded. Now this problem statements look a little bit complex, but it is very simple to understand and the solution is very easy, like it is very intuitive. They have marked this problem medium, but this question is actually very easy if you look at the acceptance percentage as well as the number of the total number of solutions that have solved this problem. So it is actually an easy problem, just the problem statement is a little bit harder to understand. So let us understand what the problem is saying. So problem is saying that you are given a guards array which will represent the position of the guards. Also you have given walls array or 2D vector, you can say whatever, which will tell the position of the wall present. Now what the question wants us to find out is, now before that question has said that a guard can see all the cells in all the four directions, that is if a guard is present here, then all the cells present here, down and left, a guard can see all that cells until and unless if there is a wall present or there is one another guard who is present. If there is these two conditions, then this particular guard will not see beyond those cells. So this is what the question is saying. In the end, after all the guards are placed, we need to return the number of cells that cannot be seen by any of the guard. So this is what we need to return. So let us understand how we will solve this problem. Now if you see this first example, the picture itself is very clear that how will we solve this question, because in this question there is no actually grid given. There is only two integers m and n, which is representing the size of actual grid, but there is no actually a grid given. So what we can do, we can simply create the grid of size m cross n, right? Now if we have drawn the grid of size m cross n, it will be very easy for us to visualize how the things will work. So let me just tell you how the actual solution will work. There is nothing else in this question. So let's say there are some positions of guards given. So this was the guards vector. Let's say there are many more, and we have the walls vector 2D array as well. So there can be many more. So what we will do, so whatever positions these x comma y are, we will mark those as 1. Let's say here is 1, here is 1 and here is 1. So we will mark those positions as 1. Also there will be positions of walls also given, so we will mark them as well also 1. Now why 1? Because a guard to another guard and a guard to another wall, they both are obstructions. So we will treat those two as same. So whether it is a wall or it is a guard, we will just mark them 1. So yes, let's say here is one wall and here is one wall, and now for simplicity I will mark these ones as yellow, so that when we will iterate over the guards, it will be easy for us to understand. So we have marked those. Now what we will do, all the other things are 0, right? All the other things are 0. Now what we will do, we will take each and every positions from the guards array and we will just simulate the entire process what question has said to us. So what we will do, we will take one guard's position, let's say this position, we will expand in all the 4 directions, top, right, down and left, until and unless we find any wall or we find any other guard. Then we will keep on marking those cells as 2 for simplicity, so that we can say that okay, these are the cells visited. So after trying on each and every guard, after trying out all the 4 directions of each and every guard, we will be able to know which all positions are visited and which all positions are not visited by any of the guard. So we will just count those non-visited cells and we will return that as an answer. So let us just dry run with the help of example that we have just taken. So let's say this is the first guard. So we will go upwards. So yes, we go upwards, we will mark this as 2. 2 means visited. So let me take a red pen. Yes, we will mark this as visited. Now there is nothing above, so we will not go. Then we will go to right. We'll mark this visited, mark this visited, mark this visited. Then we will go to left. We will mark this visited. Then we will go to down. We will mark this visited. Now there is one guard here, so we can't do anything. So we will return from here. Okay. Then we will take this particular guard. Okay. So we will first go into the up direction. So this is visited. This we will go upwards. This is also visited. Now if it has already been visited by another guard, that is some different thing. But we will still visit it. We will only not visit if there is some guard in between. Not like it is been marked by some other guard. No, we will still visit it. But if there is some other guard, then only we will not visit. So that is the main criteria. So that's why we also go upwards here. So we'll mark this as visited as well. Then we will go to the left direction. We'll mark this visited, mark this visited, mark this visited. Then we will go down. We'll mark this as visited. Now, when we will go to the right, we can see that there is one wall present. So if there is one wall present, we can't go beyond that wall. So we can't do anything. So we will just return from here. Then we have one more one here. So we will start iteration from here. So we will go first upward. So we will mark this visited. Now when we come to this cell, we see okay, there is another guard. So we will not go beyond this. So we will return from here. Then we will go to the leftwards. So we will mark this as visited. Then we will go to downwards. There is nothing. So we will return. Then we will go to the rightwards. We will mark this visited, mark this visited, mark this visited. So this is the overall final grid view of what all cells are visited. In the end, what we will do, we will just return the cells which are marked 0, because those are the only cells which are not visited by any of the guards, and walls we will not count it as 0. So yeah, we will just count how many zeros are there. So there is 1 and there is 2. So we can say that okay, there are 2 unvisited cells, so we will return 2 as our answer. So if you want, you can just dry run on this example as well, the example one, so it will help us understand in more better way. So let me just draw the grid. So the M is 4 and N is 6. So okay, 1, 2 and 3. 1, 2, 3, 4 and 5. Okay. So first we will mark all the guards. So guards are at 0, 0. So let me just mark those indexes as well. 0, 1, 2, 3, 0, 1, 2, 3, 4 and 5. So yeah, guards are at 0, 0, 1, 1, 2, 3, that is 2, 3 here. Then walls are at 0, 1. So we will mark wall as 1 also, 1 only, but with some other color, so that it is easy for us to visualize. So 0, 1 wall here, 2, 2, where is 2, 2? 2, 2 is here, one more wall here, and 1, 4, 1, 4, one more wall here. Sorry, 1, 4, one more wall here. So yeah, we will start iteration in the guards by taking each and every guard. So we will take the first guard. So this is the first guard. So we will check all the 4 directions. Upwards there is nothing, leftwards there is nothing. We will start by going down. So we'll mark this as visited, mark this as visited, mark this as visited. Then we will go to right. Right, there is wall, so we can't go beyond that. Okay, then we will go on to the other guard. So guard, we will go again upwards, so there is wall, so we can't go beyond that. We will go to the leftwards. We will mark this as visited, then we will go downwards. Visited, visited. Then we will go to the right. Visited, visited. Now there is one wall, so we can't go beyond that. Then we will check this guard. So we will check this guard. We will go in all four directions. So upwards, mark this visited, mark this visited. Downwards, mark this visited. Rightwards, mark this visited, mark this visited. In the left, there is one wall, so we can't go beyond that. So in the end, how many zeros are there? 1, 2, 3, 4, 5, 6 and 7. So in total there are 7 unvisited cells. So we will return our output as 7, and you can also see that here the output is 7 as well. So we can say that okay, this is the approach that we will apply here. So this question is just implementation based of what I just told you right now. So we will just write the code now, understand the code now, so that we can have more clarity about this question. So let us see the code now. So yeah, let us see the code now. So first what we are doing, we are creating a grid of size m cross n. We are marking all the guards as 1, all the walls as 1. Then what we will do, we will iterate on the guards vector or guards 2D array. We will take each and every guard's position, and from there we will check all the 4 directions. This is the first direction, this is the second direction, this is the third direction, and this is the fourth direction, and we keep on marking them as visited. Yes, until and unless we find any of the ones. Ones means any other guard or any other wall. So we will keep marking them as visited. In the end, what we are doing, we will check if there is any grid cell which is marked as 0, that means not grid of I, j, that means 0. So we will increment our answer, that means this particular I, j is not visited. So we will increment our answer by 1. In the end, we will be just returning the final answer. So I hope you understand this question. So thank you for watching.